Hey there, friends. Jeff Fritz here, and I'm back with another episode of C# in the Cards, and this time we're going to introduce and talk about enums and constants. Now, enums are a pretty common feature. We're going to start with those first. Folks know what these are, right? We're familiar with the enumerable values in a Boolean of true and false. But what if you could create your own enumerable types, right? It gives you a way to constrain the number of available values you can assign into a variable and make those clearly defined, as well as a heck of a lot more readable. So an enum, it's a set of named constants associated with an integral or a numeric value, right? By defining and using those enum types, it makes it really clear when we work with our code to our human eyes exactly what types we're referring to. So we can define an enum for a suit in a standard deck of cards as an enum like this, right? Public enum, we use the keyword enum, and then whatever we want to call it, suit, curly braces, and then inside there we list our values that we want to have as potential values for this enumerable type for a suit. So we can then say suit.clubs to refer to the suit of clubs in a deck of cards. So we can display the numeric value by saying display int suit of clubs, and when we execute this, you'll see it returns the value 0. All of the values in an enumerable type start counting with the value 0 and step up by 1. You see Visual Studio Code helping me there. Diamonds is 1, hearts is 2, and of course spades is 3. That's pretty easy to see, and we can be a little bit explicit about that and set those values as we want with an equals next to it as well, if we'd like. We can declare variables of that enumerable type like this. Suit, the suit of whatever your card is equals suit.clubs, and that becomes very clear for our human eyes that your card suit is a club, right? That's pretty easy to follow with. So it constrains that value, meaning that we can try and do something here like say, well, your card suit equals suit.hammers. Well, there is no hammers suit. So when we try to execute this, it comes back and we get an appropriate error here that says, there is no suit called hammers. You can't do that. Now, if you do invent a deck of cards that has a suit called hammers, let me know. That sounds like it'd be pretty cool. So we can continue with this by also enabling our enums to store multiple values of binary powers here. So consider if we have a value that we want to store multiple values in, right? So we have a variable, let's say, the days of the week that our game is going to take place, our card game night. We might want to say, well, you know what, we have card night on Tuesday and Thursday night. Friday and Saturday night are the weekend nights where we want to play cards. So I want to store both of those values in the same variable. And we do that with a feature called flags. And flags lets us use those binary values to represent multiple values in the same variable. Check this out. So let's set up a enum type called scheduled day of week. And we can define it Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And you see the values increment by the powers of 2. 1, 2, 4, 8, 16, 32, and 64. This means that I can easily set a value of, let's say, 65, which is 64 plus 1. That's Saturday and Sunday we can represent. Now that's a little bit more interesting, right? So I'll create that enum for us. So that little flags hint that you see up at the top here helps to communicate to the compiler, to our C# compiler, that these are values where we're going to actually be able to store more than one of them inside a variable. So I can continue here and I can say, well, game nights are both Friday or Saturday, right? That vertical pipe lets us OR those two values together. And if we display, well, if game nights is Friday or Saturday, when I display that, see, I get this nice value of Friday, Saturday. It still gives me that text value coming back showing Friday or Saturday. All right. Now, we can also add some convenience values inside of our enum for things like weekends are the value 65, like I described. Weekdays, which would be Monday, Tuesday, Wednesday, Thursday, and Friday, are the value 62, and it's the sum of those values. We can also say every day is 127 if we want to schedule something for every day of the week. So I can very quickly here put together a variable that says the work week is scheduled day of the week, weekends, and it will return just weekends, right? So, well, that's kind of clear, but that's not entirely clear as to exactly what values are in there. So we combined values with flags. We can, if we try that with the suits enum, it doesn't quite work the same way, right? Suits was 1, 2, and 3, 0, 1, 2, 3. So if we try and put together and say, well, the suits I have in hand are clubs, diamonds, and hearts. When I say, well, display the suits in hand, it says spades, because it's not that binary value. It's not a flag to be able to return. So it misbehaves a little bit here. So we can also parse values and convert from strings or numeric values back into that enumerable type. So I can read values like Monday and Tuesday, and it will read and turn those back into a day of the week. But I can also read the value 8 inside quotes, and it'll turn that back into Wednesday. I can also, because it's a series of flags, I can place two values here separated by a comma, and it will give me those two values properly. Same thing with the 65 here. It'll turn that back into the appropriate value. Monday, Tuesday, the 8 is turned back into a Wednesday. Thursday and Friday are recognized, and 65 is turned back into a weekend. So when we had the weekends variable there, we didn't have a way to actually pick out, well, is Saturday in there? Is Friday in there? We can use the logical AND operator to check if a value is part of that assigned value. So here, where I had weekends, I can say display weekends and Friday. Show me if Friday is part of that. And I can also say display weekdays and Friday. Is Friday a part of that as well? Well, weekends, which are Saturday and Sunday, they don't contain Friday, so I get a value of 0. And weekdays does contain Friday, so I do get a value of Friday coming back. If I had specified, well, is Saturday a part of that, I do get a value of Saturday. So you get a 0 value if it's not part of the variable you're testing against. Okay? This is very valuable if you want to use if statements to check and inspect whether a variable that's assigned in enum is equal to another enum, and you do it with flag types of constants in there. And you can use this syntax. Now, those are enumerable types. I want to make sure that we also touch on what constants are. And this is a very brief part. That's why I kind of stuck it in at the end of this episode. Constants very clearly are a value that you store that never changes. Okay? So we're going to declare that value at code time, at the time you write your code, and it will never change. The compiler will protect that value and prevent anything from overwriting it. So I can do things like say, well, if date time now hour is less than 6, you should still be sleeping. It's before 6. And I can also say, well, you should be awake. It's after 6. If the time is after 6 in the morning. Now, right now, it's 5 in the afternoon, and when I run this, it comes back and says, you should be awake. It's after 6. Makes sense. I can follow that. But that 6 is appearing in my error messages here. It appears in the test up there, and I'm seeing this magic value. I'm reusing that value of 6. And if my wake-up time changes because I'm working a little bit later in the evening and my wake-up time is now 10 a.m. because I have a later shift that I'm working, well, I don't want to have to go through and by hand update all the places that reference 6 because it's not entirely clear, right? So we can update that and use a constant instead, like this. So I can say constant wake up hour equals 6, and I'll test against that value, which it knows is 6, and I'll appropriately place that in my formatting. So when I run this now, you should be awake, it's after 6. If I change that to 10, now everything updates and I get the exact same interaction. Let's see, if I make that 20 for 8 p.m., I should still be sleeping. It's 5 p.m. now as I'm recording this. It's before 20, right? Or 8 p.m. in the evening. So, very cool way for you to reuse values. Make your code a little bit more readable when you have that magic value that you're going to carry around to a few different places inside your code. All right? That's all the time I have for this episode of C# in the Cards. Make sure you check out the website where this sample code is available. You can download the notebooks. You can give them a try on your own machine. You can open them in the browser and tinker with them, make changes, change the code, try different things in there, see how it behaves so that you understand the concepts of enums and constants a little bit better. I'll be back in a few short days for episode 12. I hope to see you then. Click the subscribe button just below. Click that bell so you can be notified when we release the next episode of C# in the Cards.